Hello and welcome to the ESM 101 training series. In this particular case, we're on to the fifth session, so 105, and we're going to be talking about lists and rules specifically. So we're going to talk about rule theory, what it means. We're going to talk a little bit about the lists and how we can use those, and some basics with some standard rules as well. So, rule theory, what is it? Well, do you need to take action? Then you need some rules. Basically, think of it this way. Rules allow us to define a set of conditions, and when those conditions are matched, we can trigger an action. Those actions could be simple, as literally just generating another correlation event, or it could be to open a case, it could be to trigger a remediation, or it could be to trigger an alert or a notification. We can have multiple actions based on the way we define the rule as well. So we can define how those operate. First, we need to understand some rule theory. I'm not going to go into all of this one. And again, if you want to look at this in a bit more detail, then please do so. Just pause and read the particular text. It's useful to understand. Typically, we're talking about a number of different ways that a correlation can occur. We can have something like a simple aggregation. So this is typically a number of events need to occur within a time frame that are the same. So we're deduplicating, we're looking at some very basic conditions, but we're aggregating a number of events within a time period that match those conditions that are typically the same. So it's a simple aggregation correlation rule. We've got a complex correlation where we've got what we call a multi-event join. Now, in this particular example, we're looking for a combination of a number of things. So we can see here that we're looking for an IDS event, we're looking for a number of attack events, and then we're looking for example, some firewall traffic to allow traffic through. Now, in that example, we're looking at a sequence. So we're seeing the IDS, attack, and firewall events in a particular order. We're also seeing that there's a number of combinations that are going on, simple aggregation as well, and that things need to complete across this complete join for the rule correlation to trigger. Or we can look at an overall longer sequence. Now, in this particular example, we're introducing what we call lists, or in this case, active lists, where we can take data, we can have a trigger, we can put that data onto a list, and that list would remain static and available for us to check multiple times over an extended period of time. If you take the multi-event join from number 2 there, you probably wouldn't want to have that running across an hour, a day, a week, a month, or a year. In that example, we want to be using something like an active list where we can take that data, we can park it in a list and have that as static data, and then refer to that data when we need to over a much longer period of time. So we can actually have that correlation trigger over a week, a month, a year, or whatever we need at that point. And it allows us to be much more efficient. There's different types of rules to consider as part of this. We can have standard rules that we can do all features. We can do all calculations and generate a correlation rule when it's triggered. We can have what we call lightweight rules that allow us to typically populate lists. Exactly the scenario we just talked about a second ago. So active or session lists. It's only got an evaluation of one type, so we can only do an action on every event trigger. We'll be talking in a lot more detail around some of those triggers in a second, and we can't do aggregation either. So it's very specific to a very certain scenario for populating lists. It does not generate a correlation or audit events. So the idea is that it's very lightweight, it's very fast, and allows us to populate lists at volume in bulk without having the overhead of generating all that additional overhead too. It is also processed earlier in the flow than the standard rules as well. So it's going to do it faster, quicker, sooner, and much lighter. We also have pre-persistence rules. What that means is we can update information in an event prior to it being written to the event database itself. So we can, in this example, we can only set fields. We can only change those fields. We can't trigger an alert. We can't trigger a case or anything. But the idea is that this is processed earlier in the flow than lightweight and standard rules. So if there's information that we need to update in the field, we can do that through a correlation rule, through a pre-persistence rule. So we can update something, correct something, change something, or even add something to the event itself prior to the actual execution by the lightweight rules or the standard correlation rules. So it's a very powerful, kind of think of this as a get out of jail card type event correlation rule to allow us to fix data that we can't necessarily fix at the event collection layer. Which rule do we choose according to this? Well, it should be fairly obvious from that point of view. Pre-persistence is if you need to update or add data to the original base event prior to doing anything else. Lightweight rules are great for updating information like blacklists, threat intelligence lists, and so on. Standard rules are great for doing simple correlations, joins, or complex rule chains as well. It's fairly obvious from there, just spelling out a little bit more detail for you to see what's going on. A little bit more on lists for a second, because I've introduced some quite complex scenarios there, and it's probably worthwhile just digging into those a little bit longer. An active list is a data store that allows us to store that data for a much longer period of time, much longer than we would want to have in an aggregation field. Now, again, aggregation is just grouping events that match, that are similar. So we can do that over a minute, 2 minutes, 10 minutes, whatever we want to do, but we probably don't want to have an open active correlation that could be occurring over 10 minutes, hours, days, weeks. In that case, we want to be using active lists to track this. So a good example is tracking hosts that are infected. So we want to have a rule that's going to pick that up and identify the command and control activity, and then we update that information and put their source IP address, host name, maybe even the username, and put that onto a tracking list. And then we can leverage that list by looking up information at a later date. And that data is not lost. We don't have to then refer back to it. And we certainly don't need to run the correlation rule again. In this example, as a search, for example, we don't need to go back through that data because it's already there in a list. We need to think about how we want to track this, but an active list is an incredibly powerful way of having that data, parking it in a small list, a small construct, think of it as a small table, and having that referred to as part of correlation rules, as part of dashboards, even part of reports at a later point as well. Just as a quick note, there are what we call event-based or field-based active lists. Event-based allows us to choose the event attributes as field names. Field-based allows us to define the fields, including the names and attributes. It's fairly obvious when you come to use them, but the whole point here is that for event-based ones, a value can be compared, and for field-based, we're comparing against the actual field itself. Typically, in most scenarios, the field-based active lists are the better option, and it's the one that you'll most likely be using because we're allowing to do the comparison. For example, in the tracking list of, say, an infected host, we'd want to be tracking things like the address. In that case, we probably want to be using the field-based to allow us to do the comparison of the addresses together. Just as a quick note there, most cases you'll be using the field-based active lists. Session lists are a little bit more sophisticated. They allow us to track sessions over an extended period of time. So typically this is to do with user logons to an application system or device, and they're populated as part of a rule trigger. And then you also have a close of the session. So if somebody logs in, you open a session. When they log out, you close that session. And then that session is stored for the time period of that particular session, again in the database and the store for the session list itself. Then those session lists can be leveraged by rules, query viewers, or reports. Really useful from a report point of view if you want to track who logged in and used which IP address at which time. Session lists are a great way of tracking that over an extended period of time, typically because things like DHCP pool allocations tend to be limited, and therefore having a actual session tracked for what user logged in, to what IP address, what session they were given, what IP address, and actually have that mapped is a great way of doing things. So that's the difference between a session list and an active list. But jumping ahead, let's go to rule basics. How do we build a rule, and what are we matching here? So we're looking for a number of things. Now, again, remember, a filter is the key aspect here. We're looking for a particular matching set of conditions. Now, it could be things like Booleans, a filter, asset categories, maybe even vulnerabilities, or are we looking up some information on an active list? We typically want to be doing some sort of aggregation. How many times is this going to occur? What's the time frame that we're looking for? And which fields are we expecting to be the same? And which fields are we expecting to be unique. And then we also want to trigger some thresholds and actions. Now, we've got multiple thresholds that we can use here, and it's really essential to understand the difference between these. So I'll actually be stepping through those in a minute. So what's the difference between an on first event to on every event, for example? It should be relatively straightforward for the common ones, but some of the more sophisticated ones I'll actually be stepping through as well. So let's just look at aggregation for a second. If we're looking at things like port scan activity, the condition we're looking for example, typically it's a firewall. So we're looking for firewall types. We're looking for a number of matches of 5 and the time frame within a minute. The things that we want to say are the same. So for this case, we're looking for identical source name, destination address, but we're also looking for unique port numbers. So typically that's how a scan occurs. Somebody one particular IP address they're starting from, typically going to a destination address that's the same, and we're trying increasing port numbers, starting at a particular number, say 50, 51, 52, 53, 54, 55, for example. If we do that within a minute, the source and destination addresses are the same, identical. The port is different, 50 to 55. The time frame occurs within a minute, and the number of matches is 5. That's a really good example of a aggregation trigger within a rule. So it allows us to detect a single source scanning a single destination and looking for a port opening. It's very simple and straightforward, but that explains the aggregation element. Brute force login, it's worth understanding, it's a little bit more sophisticated because we want to make sure that there's some elements here as well. So the condition, the restriction, the filter we're looking at is category behavior starts with authentication, and the outcome here is failure. We want to see 3 matches within a 2-minute time frame. But the fields that must be identical here must be the destination username. So the username that's been used to try and log in. Why this way? Why not have the same source and destination address? Because in this case, we want to look at, and we don't care if that username is being used by a different host. So again, this is typically what we see from scenarios where somebody is trying to break into a user account. They'll do so from different hosts to try and avoid being picked up directly. But in this case, this was a rule very easily identify that because we're just looking for the same username that's being used within 2 minutes that has 3 or more failures. So again, you can see there's some aggregation differences there, and that's the difference between unique and identical from the field matching. So just a little bit more about the thresholds here. So the on event or on threshold elements here. So on every event or first, subsequent, or every event triggers here. Here we can see that it's doing, in a case of first, it'll trigger on the first match. Subsequent will trigger on when an event arrives and there's no action was taken. So the subsequent time of that, and every will trigger on every time that there is a match. And on a threshold one, so in this case on first threshold, it'll trigger when the first threshold is met. Subsequent will trigger when the first threshold is met but no action was taken. So one has occurred, then the second time it's occurred, it'll trigger, and on every threshold, it'll trigger on every time the threshold has been met. Now, why have those different combinations of those? Well, it actually makes really great sense. So, for example, if there's a particular scenario where within your application that there is an attempt to log in, and the brute force is a good example, we don't necessarily want to take an action when somebody locks their account. So that in that case, we could use the subsequent action there. So the first time that it occurs, we don't care. But when they try to do it again, then we want to trigger something. So we can do 3 failed logins within 2 minutes. And if they do that again, then we can have the subsequent threshold trigger and go from there. So you can see that there's combinations that we can build. And in some cases, maybe we want to trigger that every single time something occurs as well. So that's why it's there, but it's worthwhile understanding as part of the actions for the rule there too. Just a little bit about time unit and time window expiration as well. Time unit allows us to set if something is met within a specific number of minutes. So, for example, if aggregation is set to 2 minutes, 2 matches within 1 minute, and you receive 50 matches in 1 minute, the on-time unit trigger was set to 1 minute. The rule would only trigger once in that 1 minute. So this is a really good way of eliminating massive number of hits in that kind of scenario, and you just have one match within that particular time unit. Time window expiration will trigger on the time in the aggregation tab has lapsed without meeting the next threshold. So it's really good at providing an indication when an attack like a denial of service has ended. Not when it started, but when the number of frequency of the aggregation over a particular time period and it gets to the next threshold. They're very specific circumstances, do not get me wrong. So they're very specific to certain scenarios within an attack lifecycle, and they're very useful to use to eliminate, for example, certain scenarios around that. So I really encourage reading the manual around those, but it's just a little bit around those time unit window and time window expiration. So let's dig into a little bit more around those rule triggers, because it's really useful to understand this. So assume our rule here has 5 matches within 2 minutes. We can see here that the first 4 events were received within 60 seconds, and then the 5th and final match to our aggregation actually received in the 60 seconds to 120 seconds, 2 minutes interval. So we get our first threshold within that hit. So if we had first threshold, so on and so forth, we would hit that within that 2 minute interval. Fairly straightforward and simple, okay? If we make that a little bit more relevant, so we actually hit our first threshold, and of course it's 5 matches within 2 minutes, but we hit it within the first 60 seconds. Now, if we have a subsequent threshold, that means that we have up to 180 seconds. Remember, it's 2 minutes. The first one matches within 60 seconds, but then we have up to 2 minutes for the next threshold to occur. So it's the maximum time period within that time period is up to 180 seconds. So that's subsequent threshold. Remember, if we don't trigger on the first one, we can trigger on the second one. But in that case, it's up to 2 minutes from the end of the first trigger. Next, in this case, we're going to look at this one. Say, for example, we have our 5 matches within 2 minutes. We match everything for the first one, the first threshold, within 60 seconds. We could then have another set of events that occur within 2 minutes. So in this case, we can have another threshold hit at 100 seconds. So we'd actually have 2 triggers within 2 minutes. So you can see that there are starting to be scenarios where I would want to do first threshold and subsequent thresholds as equally as we want to do every threshold, so we can see that we're triggering that every single time it occurs. So that's the differentiation between on, subsequent, and every. In this particular case, we're going to do a little bit more extrapolation around that. So just to extend that and say subsequent again. So in this case, we can see that the 10 events occur within 100 seconds. So we actually have one trigger at 60 seconds. For 5 events, we have a second event triggered on the 100 seconds. We have another 5 events there. And then the subsequent trigger would be another 2 minutes after that last particular threshold, which would be at 100 seconds. So we have up to, in that particular case, 220 seconds. So that's the subsequent one, just to note that one for a second. And now, finally, we're going to introduce something around the time window expiration. So in this example, we have first threshold at 60 seconds, second at 100 seconds, and we can have a time window of 2 minutes, and we could even have another threshold hit within that time period, but the first threshold must be met for the time window expiration to be triggered and available. So we've had the first threshold has occurred, and therefore we have a time window expiration, and therefore, like I say, that's a really good example of how we want to detect when something has stopped occurring, like a denial of service specifically. So we can see the time window expiration occurs at that point as well. And then just to note as well, if you do a time window expiration, you can reset and have new sets of events occur. So you can see that the count now resets at that particular point, and then we have the thresholds available to us from then on after that particular trigger. So like I say, it's great for denial of service. It's great for when identifying when something stops and when it restarts. Just a little bit about condition triggers here. So, for example, here we have 5 matches within 2 minutes, and we have 4 matches, but we don't have a complete 5th match within that 120 seconds, 2-minute period. So the threshold is not met, so no action is required or triggered. It just won't. That's known as a partial match. So if you do see anything referring to a partial match rules, there are dashboards that show this. That is what a partial match rule is. It will actually keep that open for a period of time, at which point, if an event was received late within that particular time frame, remember we're storing that based on the event times and we've got multiple timestamps. But if the event is received late, which is entirely possible, and it matches within that particular time window, then the threshold is met and then the action is triggered. But that's only in specific circumstances when the event is received late. In normal circumstances where you're receiving the events in real time, in this particular example, the threshold is not met and therefore the trigger does not occur. And a little bit about rule triggers. We can do a number of actions here. We can do things like set an event field, so we can change a particular entry in a field. We can send to open view operations, so that's typically sending to an external system. We can send to a notification to a particular group of users. We can execute a command, a local script on the ESM system. We can execute a script on a particular connector that initiated this log data in the first place, so we can run the script on that machine itself. We can export to an external system, so we can generate an XML file of the rule trigger to be picked up by an external case management system typically. We can create a new case within the system itself. We can add to an existing case that we've already created. We can add the data, specific data, to an active list, or we can remove data from an active list. Say, for example, now somebody's logged out. We can add to a session list when they've logged in, and we can terminate the session list when they've actually finished that particular session. We've also got some specifics that we can trigger around assets. So we can add a category to an asset. For example, if we see an open port because we see some data being transferred to and from, we can actually update the asset category and add that particular information to it. Or alternatively, we can remove an asset category as required as well. So that's just a little bit about the rule triggers, a little bit about the thresholds and the type of the rules that we can use as well, and also a quick summary around pre-persistence, lightweight and standard rules as well. So thank you very much.